So, dear friends, today we will see the hydrogenation reaction of cyclohexanone. Okay, there is one rule is there, 1 hours hydrogenation. According to this hydrogenation, the catalytic hydrogenation, okay, we will do the catalytic hydrogenation. During the catalytic hydrogenation in acid, okay, acid used as a catalyte. During the catalytic hydrogenation, preferentially you obtain the acyl OH or cyclohexanone. OH should be at acyl position when catalytic hydrogenation takes place. That rule is 1 hours hydrogenation. Okay, we have already discussed this 1 hours rule. That rule is different from this 1 hours hydrogenation. Okay, this rule is for the hydrogenation of cyclohexanone, and during this hydrogenation you obtain the acyl OH group in presence of acid. Okay, why this is happening? Let's discuss on this. Now, if suppose we have the cyclohexanone, okay, therefore when there is a possibility of catalyst approach from acyl side and possibility of catalyst is approach from the equatorial side. Okay, the catalyst approach from, okay, acidic catalyst approach from this acyl position is somehow this acyl position, there should be the 1,3-diacyl interaction of that side is the not convenient for the absorb of catalyst on this surface. Therefore, catalyst is prefer the surface. Okay, catalyst prefer the surface equatorial from the equatorial side, because that equatorial side is somehow less steric problem. Okay, now after the adsorption our catalyst on the equatorial side, the hydrogen is also approached from, because we know that our reactant will adsorb on the catalyst and then it will react and give the product. Okay, therefore firstly catalyst adsorb on this from the equatorial side, and then hydrogen approaches, and therefore hydrogen is approaches from the equatorial side. Then due to this carbonyl group should be the acyl one. That's why we will obtain the that kind of product where hydroxy groups is present at the acyl position. Okay, because your hydrogen is get add to the equatorial side by through the adsorption, it appear equatorial and it will be converted into the acyl position. Okay, this way hydrogenation in presence of acid takes place. Or any catalyst to use the hydrogenation, if on the cyclohexanone takes place, your OH or hydroxy groups should prefer the acyl position. Okay, the role of the catalyst is when you obtain the hydrogenated product, it dissolve, okay, or remove from the surface easily. Okay, we have to choose the catalyst which dissolve surface easily of from the equatorial side. But if catalyst not dissolve or remove easily it remain entangled with this side, then it means the reaction goes slowly. Okay, if easily it dissolve, or if you catalyst is easily remove from that side, then it will obtain our acyl hydroxyl group. Okay, this is the kinetic controlled product. Kinetic control product means that product has the higher energy. Remember that. And it looks unstable. When the unstable or acyl product is there, it is a kinetic control product, because unstable and fast reaction. Remember, kinetic control reaction is fast and it obtain the more unstable compound or more steric crowding. And if steric crowding is minimized in the product, then that product is our thermodynamic control product. Okay, that reactant goes fast and gives the directly acyl OH group. Okay, therefore, if your catalyst is not easily removed or dissolved from this side, it remains entangled with that side, and due to this, it may be, its position may be changed. Okay, it may, due to long time or prolonged, there is attachment there, therefore it may be changed the position. It may be from this, maybe from this is upper. Okay, therefore prolonged attachment might be catalyst positioning change. Firstly, catalyst is appeared from the equatorial side, and it may change the position. It may change it at the acyl position due to prolonged. It is prolonged is attached to this substrate or the reactant. Okay, if it is goes fast reaction is there, it gives the acyl hydroxyl group definitely there. And but if prolonged entanglement or prolonged it's not dissolved the surface, then it may be changes. It came from the acyl side, it came from this side. Okay, that chances is there. Okay, therefore, due to this, you will also obtain some acyl product and some equatorial product. Okay, because the prolonged your catalyst is attachment with this substrate. If it is not prolonged, if fastly it dissolve from the surface, it gives the only and only kinetic control product and 1 hour's hydrogenation. Okay, it gives only 1 hour hydrogen rule of hydrogenation product is obtained. But if prolonged attachment is there, then it can be gives this. Okay, 2 epimers is obtained. Okay, that 2 epimers is obtained or 2 isomer is obtained, and there is a mixture of acyl OH is there and the equatorial OH. Okay, there is a equilibrium is established between acyl OH and equatorial OH, and after the sometimes after prolonged if reaction is proceeded, you are not your catalyst if you not removed, prolonged reaction is there, then or if not your catalyst not easily removed the surface easily, then in this case also equilibrium is observed, and at the last predominantly you obtain the equatorial OH group. Okay, equatorial OH group means that product is a stable one. If the stable product is obtained, it means its reaction goes slowly, and if stable product is obtained, that product is the thermodynamic controlled product. And first case, it is a kinetic control product, because the unstable most stable unstable compound is produced, product is the unstable, energy is high, energy if it is high, then kinetic, this reaction is the kinetic control reaction. Okay, like that way their equilibrium is observed, and at the last equatorial product is predominantly obtained. Okay, for avoiding this we can use mineral acids mixed with the acetic acid. Then this catalyst work very well and gives the fast reaction, gives the acyl OH if you mix the mineral acids with the acetic acids. Okay, therefore for obtaining acyl OH you have to perform reaction fastly, and if for obtaining equatorial OH you have to your reaction should be slow, then you obtain the equatorial product. Okay, now one of the there is a reduction of your carbonyl group. Okay, that is M Mervyn Ponder Worley reduction, MPV reduction is there, and during this Mervyn Ponder Worley reduction, we use the catalyst is the aluminum isopropoxide, aluminum triisopropoxide is there. Okay, that reagent we will use for during the reduction of the MPV reduction by using the aluminum tripropoxide. Okay, in this case also this is our catalyst, and it approaches from the less hindered side. Okay, because this our catalyst is the big catalyst, therefore it approaches from the less hindered side. Equatorial side is the less hindered side, therefore that catalyst will be appear from less hindered side. Okay, therefore by approaching from the less hindered side, we will that isopropane group is there, isopropyl group is there, we will show this group like that. Okay, instead of the IPR we written the this is group is the our isopropyl group. Okay, therefore this hydrogen is transferred from the equatorial side. Okay, because it's bulkier, or our catalyst is a bulkier, it appears from the equatorial side. Okay, therefore like that mechanism is there, and that oxygen attached to the aluminum. Okay, therefore hydrogen is transferred from the equatorial side. You will obtain the, if hydrogen equatorial, that you will obtain the acyl OH group. Okay, therefore after this mechanism you found that you obtain the acetone is there. Okay, and actually your hydrogen is the appear is the form. Okay, then after the desorption of this catalyst you will obtain this acyl OH group. Okay, but prolonged, if reaction is happen prolonged, your catalyst is remain attached the oxygen prolongedly, then again oxidation of these groups takes place. Okay, by open air oxidation you will obtain again there is a our carbonyl group is obtained. Okay, by the it is produces that acetone. Okay, therefore like that it again attack to this, and this is again attached to this, and you will obtain again the product. Okay, therefore equilibrium, if prolonged reaction is there, then equilibrium will be established. Okay, in between there should be you can obtain the also acyl OH group and also the obtain the equatorial OH group. Okay, fast reaction it gives the acyl hydroxy group, but if reaction is prolongedly happened, more time it takes, if reaction, then the acetone or ketone is produced from this mechanism will again react to this that particular obtained state and gives the again its original that is our CO group. Okay, carbonyl group originally it's again gives. Okay, therefore prolonged reaction there is epimer, two epimers is observed, Okay, because every time this reaction is happen, therefore chances of, okay, the reaction rate, reaction length is increases, then this molecule try to obtain the most stable compound. That is the most stable compound that equatorial OH is try to obtain. Okay, fast reaction gives direct axially OH group, but when reaction length is increases, prolonged reaction rate is prolonged reaction is there, then it try to obtain the thermodynamic control product. Okay, therefore it is stable product, equatorial OH is there, therefore it is a thermodynamic control product. Instead of it, fast reaction is there, fast reaction gives the kinetic control product, but in this reaction, when prolonged reaction is there, more time your attachment of at least more time is there, then you will obtain the equatorial hydroxy group, and predominantly it observe there. Firstly, there is a equilibrium is established, and after the prolonged reaction it gives the exclusively or the preferentially equatorial OH group. Okay, like that way we have explained the our MPV reduction. Okay, now hydrogenation by using the NaBH4 or LAH, okay, it gives the hydride ion. Okay, it gives the hydride ion, and then hydride ion will, okay, when NaBH4 you use, it gives the mostly equatorial compound. Okay, equatorial hydroxy group is there because the size of hydride ion is very small, therefore it has no problem to came from the axial side, therefore it takes the axial side instead of equatorial side, because its small size, no steric hindrance is there, no steric there is a more crowded situation is there, because it's small, already small, therefore it prefers the axial position. Due to it prefers the axial position, it converted to OH and it goes to the equatorial one. Okay, that is our product control. Okay, that is called as the product control. Okay, this product is obtained by the product that is called the product control. Okay, by product controlling your product development control. Okay, that is product development control. That reaction is called as the product development control. Okay, and one of the reaction is the steric approach. That is, in this case, product development, that is steric approach control is there. If we have the ketosteroid, okay, steroid means the number of ring is there. Okay, if suppose we just take that ring, that ring is there, and CH3 is at the axial position, then you add the NaBH4 or LAH, you found that it's due to CH3, it is the steric crowding is created, therefore your H minus will take the from the equatorial side. Okay, in this case you obtain the axial OH, okay, instead of this. Okay, therefore the steric approach control, that reaction is called as the steric approach control. Okay, H minus, okay, hydride will not came from this side because there is a axial CH3 bulkier group is there. That's why that reaction is the steric approach control reaction. Okay, this is all about the hydrogenation of carbonyl group, which is directly attached to the cyclohexane ring. I hope you all get that points. Thank you very much.